Tests. Okay. The chat stay up. View. Keep. All right, I guess that works. All right, let's find something on Kaggle. Ba-bum. All right. We need this. More. Where's competitions? Competitions. Boom. Okay. Home credit stability. Learning agency. What should we try here? Store sales, natural language processing. Okay. Oh, patent law. What is this? Explainable AI for patent professionals. The goal of this competition is to generate Boolean search queries that effectively characterize collections of patent documents. You are challenged to create a query generation model. Give an input. Capable solutions. Okay, wait. Given an input of set of related outputs, a Boolean query that returns the same set of patent documents. Timeline, start date. Wait, are people doing this? Okay, score. Help patent professionals understand AI results through familiar. That is interesting, but that is well beyond what I can do. Okay. Data codes. All right. Nope. Let's start small. Okay. Home. Competitions join. House prices. Advanced reg. Okay. You have some experience with R, Python, machine learning basics. Yep. This is perfect competition for data science students who have a complete online course. Yep. That's me. Ask a home buyer to describe their dream house. Practical set of skills. Okay. ID pricing. Data. Down here. One story, train, test data. Okay. And what are the evaluation metrics? What the hell? Par Python metric. Submissions are evaluated. Yep. RMSE. Between the logarithm of the predicted value. Okay. Let's do this one. So, data, download all of it. Data description, sure. Sample submission, yes, yes, and yes. Okay. All right, now we start. File new notebook. And we'll call this housing. Let's do Kaggle housing price comp. And we want import pandas as PD, import numpy as MP. What else do we need? Open up old notebooks. We want to import all of our files that we just downloaded. Boom, 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 boom. Okay. We'll run this and we'll just start looking at the data. Okay, so actually, let me pull the overview of this. Start here, description, data, file descriptions. All right, I'll just pull this. I don't really need the text data. Text, and boom. Oh, I hate how that formats. Data fields. Plus code. We'll do, let's see, the train data. Data equal, no. Do housing data equals PD read CSV. Boom. Copy path. Done. Okay, then we'll do df equals housing data copy. Run that, and then we'll do df info. Okay. ID, probably get rid of MS subclass, MS zoning, object, lot area. Man, it's tough to read. Increase that. All right. Roof material. Okay, what does this data look like? DF head. Okay, we got ID we can get rid of. Zoning, lot frontage, lot area, alley. Might not look helpful. Pool quality control? What is that? Pool QC. Where are you? It's alphabetical, HHAK. Of course it's not. Pool quality. Fence quality. Okay. DF is null. Sum. 259. How do I do, if I just want to look at just the sum values? What is it? What is it? Chat GPT. What is the Python code just to look at the num values, or look at columns with num values? What is the Python code just to look at the columns with num values? To inspect pandas, select D types. No. What? Okay. Numeric. Oh, sorry. Non-values. With Python and pandas, you can use a combination of methods to check for the non-values. Yeah, load your data frame. Come on. What is... use the is. Wait, what? Come on. Come on. You froze on me. Import pandas, df read, columns with non. Df columns, df is not dot any. True. Okay, really? Let's do this. Columns non equals df columns. Df is not dot any and two lists. Print columns non. That's not what I want. I want to see. Well, that's not going to turn it into a data frame. I could try it. Non sum. Yeah, no, that's not going to work. Okay, I want to. Df is null. That didn't really help me. Okay. This is what I want. Because I have so many damn columns. Because I don't like that is null. It's not showing me all of it. Now, if I do this, am I able to scroll all the way over? No? Do I not have a scroll? Okay, MS zoning, lot frontage, lot area, alley, utilities, all pub, norm. Okay, so lot frontage, I can see. That's probably going to be very important for housing values. I don't want to keep doing. Okay, so ask a home buyer to describe their dream house, and they probably won't begin. Evaluation goal. It is your job to predict the sale price for each house. For each ID in the test set, you must predict the value of the sale price variable, metric. Root mean squared error, makes sense. Submission file format. The file should contain a header in the following format. You can download blah, blah, blah. Okay. So we know what it is. Creative feature engineering, advanced regression techniques like random forest and gradient boosting. I'm going to use XGBoost. The Ames housing data set was compiled by Dean DeGock. Okay, for use in data science education. It's an incredible alternative for data scientists looking for modernized and expanded version of the often cited Boston housing data set. Wait, what is this? Sorry, we can't find the page. Okay. Ames housing data set. Ames housing data set. It's in Kaggle. Okay, about the data set. The Ames housing data set is a well-known data set in the field of machine learning and data analysis. It contains various features and attributes of residential homes in Ames, Iowa. The data set is often used for regression tasks, particularly for predicting housing prices. Here are some key details about the Ames housing data set. Number of instances. The data set contains 2,930 instances or observations. Number of features, 79 different features. Target variable. The target variable in the data set is the sale price, representing the sale price of houses, data types, blah, blah, blah. Wow, okay. Wait, is this data set I'm using? The Ames data set was compiled. Okay, it is the Ames data set. All right. What do I want to do here? I want just the columns. I want to list the data frames. Okay, how do I make a data frame that is just create data frame from DF for just columns with null values. I just want to look at those. Yeah. Using isNA. Wait, did I? We have that columns with isNA, df columns. So it's, oh my god. So just don't do to list. Is that really what I'm seeing? Def is any. Def non. So then do df null equals df columns non. Did that really create my data frame? Okay. Good to know. So then I can do df is null sum. Okay. Now we're cooking. So I want to make sure I put a column here, or a comment. Create data frame to review with null values. For review, then we're looking at it. Wow. Okay, so how many? Let's see. One thing I did not do up here was df shape. So I have 81 columns, 1,400 rows. Wait, 1,460 rows. Okay, so I need to drop miscellaneous feature, pull quality, alley, because there's just too many. If I do is null sum, if I set it just a threshold from the data review, df null, and just do like divided by len of df null times 100. Boom. Okay. So anything over, oh God, I'm dropping anything over. So we are going to drop any columns with null values greater than, I'm going to say 40%. 40%, because you can't treat those. So we go back to our original data set and we'll say df drop. How do I do this? Is this right? We'll do alley. Or do I do this backwards? Okay, alley, Maz, phenotype. What else we got? Alice, Mass phenotype, fireplace, QU. Whoops. Fireplace, QU. Pool, quality. Fence. Out. And miss feature. Okay. And then we'll do comma, axis equals 1, in place equals true. Boom. All right. So now if I go df info, what do we got? Make sure alley's gone. Oh, I should have dropped ID too. Whoops. All right, let me just do that. Get out of here. We'll do df drop. Is it ID? What are you? ID axis equals 1, in place equals true. All right, now we have df describe t. Okay, so we still have null values that'll need treatment. But at least we got something going here. Okay. Subclass count 1460 lot frontage has null values. Garage built. Okay. So now we have God. df is null sum. God, there's got to be an easier way. If I just want to look at the data frame and just see sum of values without creating another data frame. and beyond just manually looking here. Okay, how do I, maybe, okay, can I just look, how can I utilize df is null sum, but only show the columns with null columns if there are null values? To use df sum in Python and pandas, only show the columns. You are so slow. Okay. Use is null. Null counts. It wants me to create a data frame. No, I don't want to list. I just want to see how many. I don't want to create another data frame. I already did that. Columns non equals df nom is any. Ugh. Is it really what I have to do again? df is null sum. And then do it again. Whatever. Is null sum. Okay, so now at least I have a little. Lot frontage, 259. So if we take the percentage again, length of df null, multiply by 100, we get 17% lot frontage. df null is null sum, len. Oh, take those off. Okay. So if I, let's look at it. Let's pull up some other notebooks. Export Plotly, final version. Case study. What's a good one here? Where's my hackathon project? That's what I'll do. Prediction, is this with XGBoost? No, I want my XGBoost one. File, open notebook. This one? Okay, so here are all my libraries. This is pretty clean. God, this seems messy. But I've never worked with this many columns. So test train, restaurateur. Train describe, treating open day. Okay. Yada, yada, yada. Train plot box. Oh. What if I do, okay, df null. I don't think it's as simple as just let's see. Can you always use Canon Imputer to resolve null values? It's working on a project with sensitive data. Stumbled on this bug. No. Canon imputation always uses just the mean value. I'm a graduate who has been doing personal data science projects for internships. Resume. One thing I've always wondered, what's the best? Well, great recommendations. Okay, what do people say about this? The way I've done it thus far is impute a column based on the distribution, yada yada. Okay. Depending on the exact nature of your data, you want to use different techniques to impute missing information, of course, but at the absolute very least, you should be using Canon as baseline. Mean and median imputation consistently performs the worst out of common techniques. Okay, good. Canon is also my default approach, but I will first try. Okay, so Canon imputation. Let's just go ahead and resolve all of the remaining null values with Canon imputation, which I did on a previous project, so I will pull that up. Upload. Where are you? Boom. Where's my projects? Project here. And Python. Boom. Okay, now that we have, we'll do 1, 2, 3, 4. No, okay. Impute missing values. And I want to, how do I, collapse sections? Okay. So where's my Canon imputer? I should probably just... I wonder if I can just reach for the data set. I'm gonna try this. So boom. Run all these libraries. Actually, what I should do, I wonder if I still have data treatment, sampling, hyperparameter tuning, imports, Optuna. Of course you don't have it. I have to install this every time. Was it pip install Optuna? Cool. So now I can import it. Okay. So actually what I want to do is just reach for the data sets from Kaggle. So maybe I can do, and what did I do for this? The URL. Okay, so can I go here to the data and just get the URL for the data sets? Yes, right? Copy. This is going to take me to the data set. Please end. No. I want the path. Where are you? Do I have to inspect you? Just give me the link to the data set. And nobody gets hurt. Where are you? Welcome to Kaggle console. I know people do this. Data, is this it? No? I want you. I don't want to download you. I just want to find you. I don't want to download all. Wait, what is this? Kaggle competitions download? Is that a terminal? What is this? API installation documentation. Should I just put this all on my GitHub? Maybe I'll do that. GitHub. We will, because I don't know if anything's sensitive in here, create a new repository. So we will do new Kaggle housing prices is available, public, yada, yada, yada. Create repository. And that way I don't have to do this every time. So then I'm going to, what did I just do? Quick setup. If you've done this kind of thing before, remote add GIP, yada, yada. Okay. Did I do something wrong? No, I just want to upload your repositories. Yes. And then I want to not set up in desktop. I want to what did I just do? Actions. Deploy node. Code. What exactly did I do? Quick setup if you've done this thing before. Set up in desktop or Kaggle highs push readme, get in it, import code to another repository. Did I screw this up? Your projects, maybe. Create your first GitHub project, new project. Okay, that's not what I want either. Wait, why? This is what I want. Why am I not getting this? What did I just create? Create a code space. Add a README file. Setting up your code space. Setting up a remote code space. Wait, am I able to... New file? No. No, right? Code spaces. Is this local? So if I install Jupyter Notebook in Python, no, this is not what I want to do. I have no idea what I just did. Okay, this is what I want. Upload files. Choose files, my downloads, open. Okay, cool. Go back here. Then I'm going to do the same thing. Choose your files. Open. Commit changes. That's what I wanted. Okay. Now I can do what I did before, which was adding a URL. So I guess I don't really need URL. I just need PD read CSV. Copy path, right? Raw. Not what I want. Download raw file, copy raw file. Is there an easy way to just get, okay, copy path. So I want to do this. That's not it. HTTP. Copy. But really, this needs to be what? Kaggle, housing prices, and then this is train. And does that work? Sure does. Okay. So I want to do the same. We want to do test data equals PD read CSV. Why don't I just do this? Call this test data. And then we just have to change this. Then I think that's it, right? Sample submission. I guess we need the sample submission too. We'll do that. Sample sub. Sample submission. Okay. All right. All right. Let's start over. Let's clean this crap up. Boom, boom. Okay, we need to be better about creating a better notebook. Okay, import libraries and data. Done. Now we need to review data. So we want to first text. Want to copy data set and initial review. View, we want to df equals housing data copy. Boom. And then we know before that there was null values. And I'm going to go back to ChatGPT and create a different data frame. Because df shape, we know that there's 1,460 rows. Okay. Then we did df info, just to look at it. We know that there's 80 columns. We need to remove ID. So after initial review, we have integer data types, object data types, floats, lots of objects, house style that we'll need to look at, roof style, roof material. Okay. Non-null. And we can see here, there's 91 non-null, 588 values, only 7 here, because we know before that we need to remove those. So we're going to create a separate data set to review. Okay, so text, we'll do initial review data set has D types. Now we'll do, make it pretty, D types of objects, integers, and maybe that was just it. and floats. And floats. There are a number of columns that have quite a bit of null values that we won't be able to treat, so we must remove. Okay, so now we're going to do this. Remove null values of columns with greater than 25%, we'll say. I'm kind of cheating since I already know that that's a good number. But what I want to do is I want to write the data frame. Okay, so nan values equals df columns, df is na any, that's right. And then I want to do df non equals data frame non-values, and then df non is null, and I want to see sum, and then I want to divide it by the length of ds non to do a percentage, and then multiply by 100. And that's where we have all this. So lot frontage, we should be able to treat. Alley's gone. Okay, so now if I put text, then we can see from the review that we need to remove a number of columns with data missing that is greater than 25%. Number and then we'll do those columns are alley, mass veneer type, whatever that is, don't care, you're gone. Fireplace, QU, and pool, QC. Oh, and fence. People don't care about fences. And miscellaneous features. Make sure that's spelled correctly. Okay. And then we also know that from previous review, we will also remove the column ID because it provides no value, since it's merely a corresponding column to index. Okay, now let's remove all these columns from df. So df drop I wonder, is it cleaner? So is it better to create a list of columns to remove from a data frame, or is it better to create a list of columns to remove from a data frame, or to write out each column name separately? What do you want to say? When deciding whether to create a list from data frame to write out each column separately, the best approach depends on the context. Scalability. Using a list is more scalable when dealing with a large number of columns. Readability, single list can make your code cleaner and easier to read, especially if you are. Okay. Okay, what do actual people say? Do you create list of column names in Python or write out each separately? Get every pandas data frame column name separately. Create a list, build list from column names, Python names. Is this purely preference? Does this really matter? If I just create a list of columns to remove. So I want to create a list. Okay. Trying to think here. If I want to create a list of column names that are greater than 25%, how would I do this? Because we have this here and we can see the values here. So at least that's correct. So I just want to return that list and create a to list. I should be able to do that, right? df non is null, and then call that list to the original data frame to remove. df non is null sum. Okay, how do I want to do this? So I want to not do that. I want to create a list. Okay, from here. df non is null sum. Can I do this on my own using my own brain? So I know I gotta start off with df non. And then I want df non columns. Okay. How do I filter from df columns with greater than 25% missing values? To filter out columns from a data frame that have more than 25% missing values, you can use pandas and Python. Yeah, of course. Calculate the total number of rows. Understand, did that is null sum. Multiply it, blah, blah, blah. Filter it out. Is null sum, did that, percent missing. So one thing I definitely need to do. That's weird. Why would they do that? Okay, I'm not going to do that. Okay. So I want to review that. Okay. So now I want to create list of columns greater than 25 with greater than 25 missing values to call upon for dropping. Okay, so this is saying, okay, filter df. So, but I'm, okay, filter df, deallocate. Filter to keep only columns with less than or equal to 25% missing columns. No, I want greater than. Remove call equals percent missing greater than. Okay, so I need to create the, so pretty much I got to assign value to this, assign a variable to that. Okay, call to remove equals boom, don't really care. df non is null sum. Okay. And no, better name, percent review, and boom. And then, okay, so remove call equals, and then from there I want df non locate, and then I need to remember what this is. Why is there colon column percent review I want greater than or equal to 25. Wait, no. Why is it 25 and not 0.25? 0.25. Print. Okay, let's just see what this gives me. What? Move call. That's not what I want. dflocate%. This is used as a Boolean mask to select columns from the original data frame. I'm just curious though. I want it to explain this code to me. Explain each part of this code. Data frame used for label-based indexing, sure. Allows you to access a group of rows and columns for each Boolean array. Percent missing. The part of the code specifies which rows and columns. The colon before the comma. This tells pandas to select all rows. In pandas, when you use loc, the part before the comma always refers to rows. By placing just a colon here, you're indicating that no specific row should be filtered out, hence all rows are included. Percent missing. After the comma. This condition is applied to columns. It's not what I want. I want to create a list. Okay. I want Python code to create lists of columns where greater than 25% of values are missing. To create a list of columns in data frame, more than 25% of the values are missing. I did that. Print the list of columns. Okay. Why is it 25? What are you doing here? Times 100. Oh, because I am multiplying by 100. I'm so stupid. Okay, so that is 25. Percent missing. Remove calls. What'd you do here? Index to list. Okay, this should be it. Percent review. Percent df non is null sum. Okay. Percent review. Percent review greater than 25, whatever, or 25, whatever. Dot index to lists. Thank you. Okay, so now we have alley, boom, 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 boom. All right. Now we have that. So now I should be able to call upon that. Do I have to do index? Okay, I want to make this as clean as possible. Okay, so then I can do df drop. Remove call. Axis equals 1, in place equals true. But how do I add ID? I should be able to do this, right? Is this a thing? Because that'll give me the list plus ID. Work. Column ID. Unhashable type list. I I just want to add all of it together. Okay, let me see if this is stupid. What if I do remove calls equals remove call ID? That's not right, right? And then I did remove calls. Yeah, no, that's not it. I want to properly append what's the Python code to add to list? To add elements to list in Python, use append. I didn't think this worked. If you're adding one element at a time, or the extend method, that's my list, sure. My list append ID. But maybe, what if I just columns with many missing, blah, blah, blah. No, don't care. Come on. All right, fix this code. The code provided, remove call, seems intended to remove one or more columns with the data frame in place. However, there could be an issue with remove call if not properly. Right. Yes, you're smart. If remove call is a single column name, remove call ID contains multiple. Is it really that easy? You just add a plus? Is it really? Let's go. What? All right. That's why we learn. That's why we do this. Okay, cool. All right. Call upon the list to remove the columns with greater than 25% and add in ID. Okay, cool. All right, so now secondary review of data set. df info, df shape. Okay, so we dropped, so 74 prior, we had 81. Drop 7 columns, 2, 4, 6, 7 columns. Okay. df info. Float integer object. Memory usage, blah, blah, blah. Okay. So now we're left with this, and we still have missing values. So the next step we want to do is, I guess first we should review the data. We have, okay, so now we're going to do the exploratory data analysis. Okay, so we're going to create 2 different data sets. We're going to do data num equals df. How do I do this? Exclude nums. Exclude. Okay, let's look at our hackathon projects. How did we do this? Data head, data column, include. Yes, yes, yes. Unique. Don't want to do that right now. It doesn't really matter since it's going to just filter out anyway. df describe t. $1460. So we still have 200 values left there, which is fine. We can treat those. Before treatment, I want to look at the data. Data num df. Data num df. What do I want to do right here? Test describe. I guess I can just jump to, yeah, let's jump to this. Univariate analysis. Okay, so I want to do df plot kind equals box subplots equals true fig size 1040 layout equals 19 to share x equals false, share y equals false. And then show. PLT show. Oops, fix size. Equals, and then close this. What I run? Kind box, subplots. Boom. Okay, so interesting. Oh, okay. Is this for education or a side project for fun? Both. I mean, right now I'm at University of Texas studying AI machine learning, and then it's actually part of my actual job. So I think it's fun, but it's also for education. Or for, yeah, it's both. And it's a lot. So right now I'm just exploring the data before I actually build the model. And we have a whole ton of outliers, but I don't know if that's going to matter with the model that I'm going to choose to use. Lot frontage, lot area, overall condition. So I think we can just let me think. There we go. This is what I wanted to do. Okay, so I can go up here and I want to do df num equals df select d types. And this will be include. numpy number n. And then here I want df categories, df select d types, exclude numpy number. And then here I can do df I don't know why I did that. I did categorical number. I did categorical data types. That was wrong. Okay, so I'm just going to do df histogram layout, same as I did before. 3 fig size equals 830. Is going back to school and pursuing AI machine learning UT hard 1 year into being an engineer and debating a master's, but want to give it dwell time before going back. No, if you're in for engineering, like UT has their master's in engineering or master's in AI, it'd be interesting. I just don't know, like I don't know. It's tough because like I see a lot of job openings and I work in technology and you see a lot of calls for like PhDs in theoretical math or masters in AI. I don't think it's hard if you're doing engineering. Like my undergrad, I had done mechanical engineering before I switched over to biochemistry. To me, it kind of just makes sense. But I don't know like where you're at in your career and your experience. I gave this a lot of thought. Okay, so you're sold. If that's this is where I struggle. So it almost looks categorical because you can kind of see how the graph looks. And what is going on with this? Are there even values in here? Garage year built. Kitchen above grade. Some basement half bath. So some of these categories just aren't going to be useful. Lot area. Okay, you have year built here. And then year sold. Month sold. Sale price, right skew distribution. So there's definitely outliers up here. Yeah. So I don't like this column. So pool area. Oh. Well, I think this just needs to change to 3-season porch. So some of these columns are just yes or no. But they're here. They're given as number values. Enclosed porch. Okay, so if I go here, back to here, open porch, yeah, the square footage. Ugh. So lot area needs removed. Basement finished square footage. Total basement square footage. What's the difference? Type 2 finished square feet. Unfinished square feet. Quality of second finish area if present. Why the hell am I even doing this? All right. I think there's a lot of columns here I just need to get rid of. But should I run the model first before getting rid of it? Okay, I feel like I need a notepad. Because miscellaneous value, okay, columns that need further inspection is okay. The one thing I don't like about Google Colab is I can't split the screen. Can I? No, you can't, right? Like, I want to be able to split the screen so I can make notes. Because I don't think, like, I need to inspect some of these columns. Like, misvalue. Like, what are you? If I do df misval, put like unique. Is that what I want? Okay, there are different values. It's just so skewed. I think it's so skewed that it's just not going to matter. Same with like probably, let's look at pool area. I would say this is the most boring part and most important part of building models is this exploratory data analysis. Okay. But if I do, what is unique sum? Is that what I want? No. What is it? Is this? No. Damn. What is that code? df miscellaneous value. N unique. That's what it is. Sum. Or is it just, I don't have to put that. New. Where do I get the list? Is it two lists? Sum. Okay. Tell me what I'm doing wrong, Gemini. df unique two list sum. Suggested changes. Okay, I think it's that. df miscellaneous. Okay, or convert to list. That's just not working either. All right. All else fails. We'll go to ChatGPT. Write Python code to show unique values in a column and total amounts. Along with the respective. Is it really value counts? Did I just forget that? Yeah. This is why repetition is important. There we go. Okay, that's what I wanted. That's useless. Like, that's not going to tell me anything. Probably same here. Pool area, yeah. Out of 1,460 columns, most of them are one value. So that's got to be useless. But can I write is there Python code to evaluate every numerical column and find where it's so right skewed? Okay. Write code to evaluate columns and find where only one value comprises greater than, let's say, 75% of all values. Value counts, sure. Define a dictionary. Okay, for column and DF columns, max percentage. Okay, this is where I want to make sure I understand this because I haven't seen code like this before. Explanation. Yeah, already know that. That's the column names. DF column value counts normalized true. Okay, the normalized true parameter turns the counts into proportions. I don't think I want it to be. Why would I want it to be proportional? This calculates the frequency of each unique value in the column, normalized to show proportions rather than the counts. The normalized equals true parameter turns the counts into proportions. Why would I want it to be proportions? Why can't I just have a percentage? With iLuck, this selects the proportion of the most frequent values. Is that why? Times 100 converts proportion per percentage. Dominant value columns. Where am I at here? Oh, wants to store the columns into there. Okay, so then dominant value columns equals max percentage. Columns where a single value comprises more than 75% of all values. For column percentage in dominant value columns. I guess we'll write the code and then we can evaluate the output to see what it looks like. Because I don't want to have to go through each single column, and there's got to be a faster way to do that, especially when there's so many columns that it looks like 3-season porch. Yeah, but what should be categorical though? So like if you have a 3-season porch, does that affect the overall price by just merely having it? But then you have what's called imbalanced data where it could, but I guess does that really matter more on the classification models? Because we have so much skew, like here, left skew, half bath. Like some of these are just categorical, I guess. I mean, technically, this like basement full bath could be continuous, meaning you could have an endless amount of basement baths. I'm half tempted just to create the model and just see what it does. I do want to look at, where's it at? Ugh. Yeah, maybe that's going to be a mess. I don't know if I want to actually create the correlation matrix on this. Screw it. Let's do it. Let's do 1, 2, 3, 4. Do bivariate analysis. And then we're going to import plot like correlation matrix, categorical. I don't know why I call it categorical in my hackathon project, because it's definitely the numerical columns. Figure equals FF to create FF. Okay. We're just going to do it. Core matrix equals df num core. I guess I could just show it this. Oh. This probably, well, that's got a lot area and lot frontage. Of course, that's going to have high correlation. So some of these are going to be so heavily correlated that we can just remove them. So I guess I do have to go through this exercise, don't I? Shoot. Okay, fig equals ff. Do I have figure factory imported? Do I have plotly imported? We're going to find out. Create annotated heat map equals core matrix values. X equals list core matrix columns, and y equals list core matrix column index. Annotation text equals core matrix round. Oh, this thing's gonna be huge. What did I just screw up? That's right. Show scale equals true. And then we show. Something tells me that figure factory is not imported. Look at my libraries. Plotly graph objects, and that is correct. So imports plotly figure factory as ff. Run that. And then we go back down here. Data frame object is not callable. Excuse me? Core matrix. Core matrix. What do you mean it's not callable? Core matrix columns. df.core. It's df.num, numerical columns. Core matrix. Data frame object is not callable. What did you do? Annotation, text, core matrix. Oh. Round values. Whoops. All right, how big is this boy going to be? Unreadable. Almost. Okay, so now I can look at here and see where the correlated columns are and see if there's anything that I can remove. All right, so yellow's obviously the highest. Okay, so like here, garage cars and garage cars and garage area. Should be able to remove one of those. What else we got? What we got here? Year built and garage year built. I guess you could have an add-on garage. But yeah, year built and garage year built. Is that going to affect home prices? Just based on the fact that, like, I think all that would matter is if you have a garage. But I want to be careful not to impute my own thinking instead of letting a model decide what data is important. But if you let a model run with too much data, then it could also cause problems. But we'll know that based on the root mean squared score that we get after we run the model. Because I guess we could run it and then we could always go back and just let XGBoost decide what is and isn't important. But there are some high correlations. Like I would say that is probably too high to let alone. And then also year built, garage year built is probably too high to just leave it for a machine learning model to decide, because it does need a little help. But I don't see any other. Oh, here's another one. Oh no, yeah, right here. Total basement square footage and first floor square footage has high correlation, which makes sense because obviously you're going to want the basement to just mimic the square footage of the floor above it. So potentially I could get rid of 3 columns. What are you? Ground living area and total rooms above ground. Also high correlation. So do we ask, okay, let's just ask the internet. Data science question. Should you remove columns with greater than, I'll say, 80% correlation? That's probably tiny for you guys. Okay, machine learning. When to remove correlated values? Data science stack exchange. Can somebody please suggest what's the correct stage? You do not want to remove all correlated variables. It is only when the correlation is so strong that you do not convey extra information, which is what I'm thinking. This is both a function of the strength of correlation, how much data you have, and whether any small difference between correlated variables tell you something about the outcome after all. The first 2 you can tell. Okay, so just like everything else in data science, it's not going to. Hey, thanks, Jack. So just like everything else in data science, there's the science that meets art. And you're always, especially in class, everybody's looking for like this black and white answer. Like, I want to know when I can remove values, or when should I treat them? How should I treat them? And of course, I mean, just like with science, there's no right answer. Same with law. Like, using my legal background, like, everyone looks for black and white. Like, you do this, this is the outcome, which of course is not. But I feel like there should be such high correlation. Printing columns with correlation is greater than 80%. That you should be able just to decide, I'm going to remove these. So like even here, like this person, obviously they went on Stack Overflow because they saw 80% correlation between columns. I don't necessarily need to do this. I just want to remove them. I think what I'm going to do is just build. It's so much data. I mean, this is so much. Even like the hackathon project I did previously, and actually I got second place in this one, building a model to determine revenue for a list of restaurants based on data. That it was not near, like, even this was not near as big of a data set. This is the largest data set I've personally so far have had to deal with. Okay, so we have age. And what did I decide over here? I think I had some stuff that was like 90%. Okay, we're just going to remove. We're going to try it. Okay. So let's see, text. We can see strong correlations from a number of columns that we'll remove prior to building out our model. That's what we're going to do. Okay. Those columns are, what do we got? So garage cars and garage area. What is garage cars? Is it the number of cars that can fit? Where are you? Garage cars. Size of the garage and car capacity. Okay, I'm going to keep the area. Right? Yeah, I'm going to keep the area. So we're going to remove garage cars. Because I feel like just from common sense, you would rather care about the square footage than how many cars. Because, like, I drove a Raptor. Like, you're not going to be able to fit the same amount of Raptors in a garage than you are any other type of vehicle. Okay, so we're going to remove that column. What else? We have more. Searching. Okay, this one. Total basement square footage and first floor square footage, which I said makes sense again because you would assume, at least my experience growing up in the Midwest, that the basement correlates strongly to the available square footage of the floor above it, which isn't always the case because my buddy in Denver's got a tiny basement. But it's just a high correlation that I don't think it matters. So, between the two values, I think first floor square footage is probably more important. So I want to remove total basement square footage. Total basement. In my head, though, it just sounds like it should be important, but there's just I got to remove my own personal bias from what the data tells me, and anything greater than 80% correlation, I just want to get rid of. We can always go back and fix it. I just think there's too much damn data points. Okay, I know we have more. What is this one? Year built and garage year built. I'm going to keep year built. Garage year built. Like, I get it, but do you have a garage? I think that's what people care about. Which is where? Oh, garage square footage. I mean, if it's 0, then there's no garage, right? Okay, so I'm going to remove, garage year built. All right, is there any more? Garage area cars, we already removed that one. Searching, I already moved that one. I mean, we still have strong correlations. Okay, here's one. Overall quality and sale price. That's interesting. Overall quality and sale price. That's probably good for the model. I don't see these two as closely related as I do the other columns. So I'm gonna leave that. Same with ground living area and sale price. Okay, this is interesting. So we are going to be evaluating sale price, and I can see here, and my assumption is that the model is going to show us that they're going to leverage the importance of a lot of these. Is there a strong negative correlation? There really isn't. I'm curious if this is telling me that, the most important, we have so many columns of data, but the most important ones, overall quality, and how's that determined? Where are you? Overall quality, overall material and finish quality. I mean, that just makes sense that if you have great material and great finish quality, you're going to have a higher sale price. The worse, you're going to have a less sale price. Okay, that totally makes sense. Subclass, overall condition, that's weird. That there's little correlation there. Basement finish, garage area, garage cars. See, those are two. We don't need both of those. Garage year built. Where's year built? Year sold. Year built. 52. Okay, so yeah. This is another data point that I can use to know when I should be able to remove columns because they're just so close in the importance related to the sale price that we're going after. Enclosed porch, screen porch, a lot of this stuff. Okay, so I think I'm good to go on just removing these. So we'll do DF drop again, and then we'll just do garage cars. Is that the right? Garage cars. Cool. Total basement square footage we'll remove, and then garage year built. Axis equals 1, and then in place equals true. Boom. Oops. Okay, what are the actual total BS no N? Boom. Now we have a smaller data set. We're slowly creeping down. We still have to deal with missing values, but XGBoost deals well with missing values in the regression models. So because I'm using XGBoost, I might leave missing values, but I will make a note here with text. Let's see. Missing value imputation. So we're just going to say because we're choosing to utilize XGBoost for our regression model, we're going to first leave the values that are missing and outliers as is, and let XGBoost run. Now we can actually build the model. Okay, build. And for that, I will definitely have to reference my prior work here. Okay. Boop, 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 boom. XGBoost regressor train. What exactly did I do here? So there's where I trained before, but what did I do here? This must have been my random. Yeah, okay, this is my randomized search. We're just going to skip the randomized search because we know Optuna is way better. But we do need to create the test data. And if you don't know, machine learning models only handle numerical data, meaning a lot of this it still needs treatment, don't it? Damn it. No, we can leave. We'll leave as is. The categorical data does need to be adjusted. So you can see here, like, get dummies. That's going to turn the categorical data into a bunch of columns as true or false. You can kind of see it here. So it'll be like 1 or 0. 1 means true, 0 means false. But before, like, open sitting available, and then there was probably like different ones. Or you can see like restaurant location, near business hub, near party hub, were all one column. But the near business hub and near party hub were the values. But it changes it to a Boolean type of column as true, false. And that's what machine learning models are better at. Well, they can't interpret string data, so there really is no choice. Okay. So now I need to create my data. So first we create an X and Y. We know sale price is what we're going after. So X equals df drop. We know sale price, right? Sale price, yeah. Sale price, and that's on axis equals 1. So we drop that, and then Y, we pop that. df pop sale price. And now we have our X and Y, and we can now treat the X column. And then we'll check the Y column. Make sure we're good to go. 1460. Okay. So, boom, boom, boom. Yeah, see here I did it right. X categorical. Okay. So now I want to take X categorical. I need to segment those out, which would be X select data types, exclude numbers using NumPy to call those out. So I get integer and float. If I just use regular Python, it's not going to do that for me. And then I get dummies. I do xdum equals, use pandas library to get dummies, and I call on the x categorical. I guess I have to combine these columns. So first I actually do need xnum equals x select data types include, and I do np number. And then I should be able to skip that. I don't really need to look at these. I don't need to transform. I'm not going to do that. All I'm going to do is combine the columns here. So then combine the columns back to a singular x data frame. So x equals PD concat xnum and xdum axis equals 1, and then I want to make sure I look at it. Okay, so let's see what it did. As you can see here, so sale type new, those were changed all into individual columns as Boolean, true or false. And now my model should be ready to train. And for that, I'm going to skip over randomized search, and I'm going to use Optuna. Okay. So I need, okay, now we can train the model. 1, 2, train model. X train, X test, Y train, Y test equals train test split. X, Y, test size equals 0.2. We'll do 80-20 split, random state, make sure we're using the same. Equals 1. Boom. And just for practice, I'm going to retype all of this for Optuna hyperparameter tuning without pruning the model. We're going to define the objective, trial. Boom. Parameters, sure. I don't think I need this. Oh yeah, I do need to keep it indented. Model equals XGB regressor model. We call upon the parameters. Evaluation metric, we know given to us is room meet squared error. Then we do a model fit. We want it on the X train, Y train. Yes, that's right. Eval set equals X test, Y test. Right? Yeah, X test, Y test. Verbose equals false. And then Y predicting equals model predict X test RMSE score equals NP square root mean squared error Y tests, Y pred that I called upon. And then we'll do a return of the RMSE score that I just created. Okay, and then study equals Optuna, create study. Direction, we want the root mean squared error to be as small as possible. So we want to tell the model to find the best parameters with the smallest root mean squared. And then we want to optimize that. We want to optimize the objective that we just defined, and then the number of trials we'll have it run. First, we'll do 50. And then we're going to print number of trials. Just doing that. Formats, length, study trials, print best trial equals study best trial. Print, what am I doing here? So print I'm calling a trial. Oh, trial value. Okay, so sorry, I don't know why it's doing that. Trial value. The format the output. 3 decimal places. Format trial value, and then for key value in trial parameters items. Print what do I do here? Print the values, formats, key value. Okay. All right. Got an unexpected keyword argument end trial. Is it end trials? Oh, end trials. Trial is not defined. Trial suggest. Oh, so stupid. Okay, trial. XP regressor is not defined. Why is that not defined? Is that not in my imported libraries? Oh, I have classify. That's why. Import XGB regressor. That's what you don't get for checking. Run the libraries. Okay, that should help. Now what's not defined? Parameters, that was misspelled. What we got here? Not defined. That should be a scikit metrics, I'm sure. Where's my metrics? Mean squared error. So when I go down here, now I should run. Now the model runs. Trial 0 finished. And the model is learning. So while it's doing that, let's see what the leaderboard. So this person did 2. I don't understand their model. Performs so good. Like everybody's well nested together. But this person. Who are you? Kaggle expert. A Kaggle expert is currently in a beginner competition on Kaggle. Appreciate it. Do you have notebooks I can look at though? Competitions. Completed competitions. I want to see your notebook, brother. In Shenzhen, China. Wizard and Oracle. Cool. Thanks for contributing to a beginner competition. The only way I'll forgive you is if I see your notebook. Email spam classification code. Email processing. Is this the spam one? Oh, cool. Okay. What are you using? So it's a bunch of definitions. Wait, what? Path original. Spam ham classification. Am I missing something? What did you do here? Great job on extracting the email body and removing HTML tags. Congratulations on a well-executed project with clean code and insightful explanations. I extend my sincere appreciation for sharing this excellent work. Cool. So, I know Beautiful Soup allows you to review HTML. So, email origin, return path. Is that what this was for? Text, and then the output. Okay, oh, do you feel pressure? Email origin, drop duplicates, subset text. How's our model doing? Still learning. Trial 46. This is where computational power. This is why I'm not doing it currently locally on my computer. Where was I? Like if this guy used like a neural network to do this instead of like the regression models that it asked for, that would be, I mean, whatever. It's not like you win anything in this competition. Yeah, predict sales prices, feature engineering, random forest, and gradient boosting. I'm using gradient boosting with XGBoost, which is called extreme gradient boosting. Yeah, here it is, XGBoost. Implement lasso regression to avoid multicollinearity. Includes linear regression, random forest, and XGBoosts. Fun with real estate. Okay, that's cool. If I go here, what's it take me to? We can't find that page. Cool. You're broken. For all participants, the same 50% of predictions from the test set are assigned to the public leaderboard. The score you see on the public leaderboard reflects your model's accuracy on the portion of the test set. Okay, so then all I'm going to do today to finish off this morning is run this initial model, and study object has no... Oh my God. I misspelled trials. Trials, trials, trial, trial, trial. So now I got to rerun the model. Cool. All I want to do is get to a place where I can at least submit like a minimum product. That's all I care about at this point. Is getting through it, getting my reps in, doing these kind of early on machine learning, gradient boosting models over and over again. Because the one thing that people don't realize is that, yeah, generative AI is really great. There's a lot out there working with LLMs. That's what you see. But there are more basic type of models that help businesses optimize, which are fantastic. Just like XGBoost, something common that if you were to go to school and learn machine learning or artificial intelligence yourself, you can help implement in your day-to-day, no matter what role you're into. Like for me, I see learning this as equal to knowing kind of like advanced Excel techniques. That's how I see this. And I think that's not something that's easily understood by people in like leadership positions in different areas of business. But I think if you were to go forward and understand how it can help your own day to day, that's where I see it. Like for me, looking at business, being able to do like what's called a K-means clustering analysis to be able to put different segments of customers together, and then be able to kind of strategize and attack in that realm. I think that is a pretty cool use case for understanding how to develop your own machine learning. So in that sense, I want to be able to get my repetitions in. But also, just, yeah, I mean, obviously, it's people consider it the fourth industrial revolution. I feel like if you don't know it, you risk being left behind. So that's why we're here, and we're going to continue sometimes to stream when available. Like I took today off of my current job, and just be able to see, okay, so best trial. I think it's really cool to just like see the model learning. So in root mean squared error, what we're talking about is looking at, let's see, explain RMSE images. This. If this is our model and we're fitting it with a line, we want to minimize the distance of actual value from the predicted value from our regression. And the smaller root mean squared error is, the more closely it is to actual value. So that's why we set it to minimize. And we let these hyperparameter tuning models like Optuna that you can import run and do its own thing. Did I misspell something again? Frozen trial object has parameters. Key value and try. Okay. That's twice now. Trial params. Run it again. And stuff like this, these little errors that I need to get better at and finish and understand. Why? For key value and params. Oh, params already defined. Okay, just let it run again. Get rid of that, get rid of that. Then we run it on the test set. Honestly, I didn't even look at what the sample submission. ID, sale price. Okay. So this is just like what I did for my hackathon project. Finally, hopefully we'll get an output. Keep misspelling, mistyping things. 10:30. Probably wrap this up after this runs. Messing around with all of this new streaming, something that I used to do years ago. I guess in the meantime, maybe we can hop on Twitter and see if there's any. Actually, you know what? I like going here to Medium and going to like towards data science. Where are you? And see, okay, towards infinite LLM, how to boost the performance of Python using the caching techniques. See, I don't know what this is. How to boost the performance of Python using caching. Advanced but out-of-the-box caching decoration in Python. Not something I'm going to learn right now. Where are we at? 42. Keep going, little buddy. Please no errors. I do not want to run you again. What are we using? CPU? Yeah. Okay, cool. All right, number of trials, value. And these are the parameters that it found that is best for XGBoost. Okay, so now let me reference back to my previous project. Oh yeah, let's look at the feature importances. So if we do fig import, we'll do Optuna. This is the cool thing about Optuna, is being able to see the visualization. Plot param importances, study, fig update, layout template, plotly dark, yes please, title, feature importance, title, x equals 0.5. Figure, did I capitalize something? Title X. Ugh. Wait, why is it showing me? No, this is not what I wanted. Oh. That's what I wanted. Cool. Okay. All right. I think that is enough for today.